In this video, we're going to look at the amortization formula, which is on page 31 of the tables. It's used for calculating loan repayments, and it's on the basis that the loan repayment is at the end of each period. So if you imagine that we have to pay €100 in a month's time, and the rate of interest is 2%, 100 divided by 1.02 is 98.04, rounded off to 2 decimals. So that would mean if we invested, cross multiplying 98.04 at 2%, it would be worth €100 in a month's time. So the first repayment, if this is my mortgage formula, my repayment is the amount that I've borrowed by 1 plus the interest to the power of 1. The second repayment in 2 months' time is 1 plus I to the power of 2. So I'm going to borrow money over a long period of time. The amount that I'm paying back, if I'm paying back 100 a month for 25 years, in 25 years time, that 100 will be 25 by 12. There's going to be 300 payments on my mortgage. So if I divide 100 by 1.02 to the power of 300, we get a tiny figure of just 26 cents. So if I invest 26 cents for 300 periods, getting 2% at a time, it grows all the way to 100. So this is where this amortization formula comes in. Plus all the way to whatever the last payment is, A over 1 plus I to the power of T. Now you might notice here that we actually have a geometric sequence, where we have my first term A, and we have a common ratio. What's my common ratio? Well, I'm multiplying A by 1 to get my A on top, and on the bottom I'm multiplying by 1 plus I each time. So the geometric series that we've seen already, geometric series, is used to help us prove the amortization formula, which you do need to do at Leaving-Cert higher level. Geometric series is the sum of all the payments is equal to A times 1 minus R to the power of N over 1 minus R. And my A I have here is this one here, A over 1 plus I. And I have my ratio, which is this guy 1 over 1 plus I. So this is what P will become. P is equal to Sn. So we're looking to get this formula up here. A is equal to, so we're going to end up with A on its own. So we're trying to isolate A in the amortization formula, which will be the amount that we pay back every month. So A is A over 1 plus I to the power of 1, or just A over 1 plus I, times 1 minus my ratio, which is 1 over 1 plus I to the power of N. And on the bottom, I just have 1 minus my ratio, which is 1 minus 1 over 1 plus I. So there's a couple of things I do here. 1 to the power, this is 1, I'll just do it up here, 1 over 1 plus I to the power of N, which is this guy in here. It's just 1 to the power of N, and 1 to the power of anything is just 1, so it's going to be 1 over 1 plus I to the power of N. And then I'm going to simplify this fraction on the bottom as well into one fraction. So on top, A over 1 plus I, and P is equal to all of this, times 1 minus 1 over 1 plus I to the power of N, divided by, on the bottom of this fraction, on the bottom we're going to have 1 plus I, and on top I'm going to have 1 times 1 plus I, which is 1 plus I, and minus 1 by 1, which is minus 1. So what I'm going to get is A over 1 plus I times, now this is going to be a simple fraction too, I'm going to cross multiply, and I'm going to have 1 plus I to the power of N by 1, 1 plus I to the power of N by 1, and then minus 1, and then on the bottom I'm going to just have 1 plus I to the power of N times 1, or just 1 plus I to the power of N. So that's simplifying in there. And on the bottom I have I over 1 plus I. Now dividing by a fraction, I'm going to turn it upside down and multiply. As you can see what's going to happen here, the 1 plus i's are going to cancel, so P is equal to I'm going to put this guy to the front of this whole expression on top. So it's going to be 1 plus I over I, turning that fraction upside down, times A over 1 plus I, times 1 plus I to the power of n minus 1 over 1 plus I to the power of n. So these 1 plus i's cancel. So if I multiply p by the whole bottom, it's going to be p times I, this I, times this 1 plus I to the power of n is equal to what's left on top, which is a by 1 plus I to the power of n minus 1. And to get a on its own, I have to divide by this. So p times I times 1 plus I to the power of n divided by 1 plus I to the power of n minus 1 is equal to a. Let's just double check that that's right. P times I times 1 plus I to the power of n. But you know it's going to be right. P times I times 1 plus I to the power of t, we used n here, over 1 plus I to the power of t minus 1. So at this point, you could say n is equal to t, therefore, and change your n to t's, but this is the proof of the amortization formula. So practice this a few times before going on to do some questions that relate to mortgage payments.